Okay, this is the walkthrough for the midterm fall 2022. So here's question 1 from exam A. I'm going to do exam A. Your different versions have the same questions, just the answers in different order. So please refer to version A when you need to find this. Okay, so let's solve our first arithmetic equation. So we have 3 different things we're adding together. We do have parentheses showing the area of operations. So let's start with the one on the left. We'll work right and we'll add them all together. So if we're going to add these two numbers up top together, these two, we're going to take a look here and we'll see that we have oops, that we have 4 decimal places, 4 decimal places. So this will go to the 4th decimal place when doing math. So up top we will have 1, 2, 3, 4, 5, 6, 7 sig figs. And when in doing math, we'll have 4 decimal places in case we need to know. Down the bottom, we're adding these two together. Both of these have 2 decimal places, so we get to keep 2 decimal places. So down the bottom, we'll have 4 sig figs. So we don't have to worry about the decimal places up top anymore. 4 sig figs divided by 7 sig figs divided by 4 sig figs, which means whatever this answer is has 4 sig figs in it. Okay, let's do this one. We do this math here. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can only keep to the 7th decimal place. 1, 3, 4, 5, 6, 7. So that means we'll have 1, 2, 3, 4, 5 sig figs up top. And down the bottom we have 1, 2, 3, 4, 5, 6 sig figs. So after the math, whatever there is, we can only have 5 sig figs in this value. What about this logarithm? Well, we have 1, 2, 3, 4 sig figs, which means when we do this logarithm with 4 sig figs, we have to keep 1, 2, 3, 4 after the decimal place. Okay? So that's what we have. So there it is. So let's look at the math for this first expression here, which is 4 sig figs. So we can keep to this minus 30.44 245 whatever. Okay. Now for the second one, we can keep 5 decimal places. So 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5. So we can keep 0.86690 200. And then lastly, our logarithm we're going to add together as well. Minus 2.1899019. And we can clearly see the largest error is in the 2nd decimal place, which sets this, which means our answer can only be reported to 2 decimal places. That 5 will round it up, and our answer will be E. Okay, so next question. Same math here, so we're going to do PEMDAS on this first, and then we'll multiply it by this logarithm, see what we have. So we're going to add these two things together. You see that our largest error in this one is in the ones place, and then this is the second. So we can only keep to the ones place when we do this math, right? So that 7 would round it up to a 6 if we had this, but we can only keep to the ones place, which means our answer up top has 1 sig fig, right? Because that 3, 2, 5, right, or 4 there are gonna remove each other, okay? So we have 1 sig fig up top. We have 3 sig figs down the bottom, which means whatever this is, it's 1 sig fig. We're going to multiply that by something that has 3 sig figs here, which means we're going to keep to the 4th decimal place. So this actually has 3 sig figs, but it has 4 digits. So either way, when we multiply 1 times either 3 sig figs, but it's actually 4 digits when you do the math, because we went through this, so the number you would use is 4. We can only keep 1 sig fig. So the answer is A. Okay, so let's figure out how many sig figs for this ruler. So let's measure this. So we're going to figure out what this is. That's 0.297, right? Because it's greater than 297, but less than 298. And this is going to be the 6, 7, 8, I don't know, maybe an 8, 2. So 8 is there, and then we estimated 2. And we're going to minus the beginning of the ruler, which is 292. And then 7, and then 3 maybe? Something like that. I don't know. 8 to a 7, which is gives us 12. So 9, 0, 5, 0, 0. That will give us 3 sig figs. Okay. Select the definition of significant figures. Hopefully you know this one, right? It's all the certain digits plus the first uncertain digit. There we go. I'm circled the wrong one, right? So all the certain digits plus the first uncertain digit. Okay, report the following arithmetic with the correct number of sig figs. So notice everything is in 10 to the second power. So we're just going to take all of these numbers and bring them to 10 to the second power and then add them together. So if I want this to be in 10 to the second power, I'll move the decimal place over 1. That's 10 to the first power. 10 to the 0th power, right? 10 to the first power, 10 to the second power. So 0.0000263 times 10 to the second power. What about this one? This one's already at 10 to the second power, so 5.4563. What about this one? Well, 10 to the first, 10 to the 0, right? 10 to the first, 10 to the second. 0, 0, 7, 4, 6. And this is 10 to the first, so it goes over 1. So 0.43453 7 times 10 to the second. It's easy to see the largest error is in this 5th decimal place. So we can only keep to the 1, 2, 3, 4, 5th decimal place. That 6 will have it round up. And so the answer is B. Okay. A student calculates the average and standard deviation for the volume of seawater in a tank. Comes up with this average and standard deviation, and this is the gauge that was used. So rule 1, we report our error with one significant figure unless it begins with a 1 or 2, in which case we keep 2. Rule 2, we report the answer, so it's the same precision as the error. Rule 3, we compare the instrument error. So let's just pick a place and lay down a dot. Right, so there. So what is that number? Well, that number is greater than 100, but less than 110. So it's about 107, right? 107, we're certain of that. Right, 105, 106, it's 107. Right, that would be 107. And I don't know, I'm going to estimate a 0.7 there. So the first number that doesn't have a line is this. So this is our uncertainty. So our instrument error is plus or minus 1, which is larger than that number. So that 5 will round up to 6, and we'll get 7. That is the answer, because that is underrepresenting our error. A student calculates the average and standard deviation for pH of an unknown acid is this number. The pH meter used is shown below. How should you report the results? Rule 1, you report the error. You report the error with one significant figure unless it begins with a 1 or 2, in which case you keep 2. So this 6 would round up that 7 to 0.8. Rule 2, we must match the number to the error, right? So that 6 will round up to 4. Rule 3, are we doing better or worse than the instrument? Well, that instrument is, let's make it pretty. 0.8 is definitely bigger than 0.1, so the answer is D. A student calculates, next one, the average and standard deviation for an unknown acid is this. The pH meter is shown below. Rule 1, we report the error, right, with one significant figure, at least begins with 1 or 2. So this does not begin with a 1 or 2, so we're going to keep 1. And that 6, however, will round it up, right? So we'll get 0.1. But now it does begin with a 1, which means we need to keep 2 significant figures. Okay, we talked about this in class. So we have 2 significant figures, so we have to report rule 2 now. We have to report that to the correct number of sig figs. That 3 will not have it round. 7.56. And rule 3, are we doing better or worse than the instrument? The instrument is 0.001, so this error is worse, so this is what we're going to keep. So for 8, A is the answer. Number 9. A student calculates the average and standard deviation for a pH of an unknown acid as 1.56 plus or minus 0.0048. The pH meter used for the instrument is shown below. How should the results be presented? Rule 1. We report the error with one significant figure unless it begins with a 1 or 2. That 8 will round it up. Rule 2. We report the answer to match with the same precision as the error. Rule 3. Are we doing better than the instrument? The instrument is much larger error, so we cannot use this one. We have to use the instrument error. And so we just have to match that to the instrument error. That 2 will not have it round. So the answer here is E. Okay. The pKa of an acid is reported as 10.23. The corresponding value for Ka is shown in your calculator as this. Report the concentration with the correct number of sig figs. So this is the pKa, which means this number here is a logarithm. And in the logarithm, all the significant figures are after the decimal place. So this has 2 sig figs. So we need a corresponding Ka that has 2 sig figs. The answer is D. An acid has a Ka value of 1.723 times 10 to the negative 11. The corresponding value for pKa is shown on your calculator as this. Report the pKa with the correct number of sig figs. So this is a regular number, and we're going to take a logarithm of it. This number has 4 sig figs. So we need to have 4 sig figs in our pKa. And remember, sig figs are only counted to the right of the decimal place. So we need 4 digits to the right of the decimal place. So the answer is A. A student measures the mass of a precipitate for 6 trials using a balance shown below and calculates the average and standard deviation as this. How should the student report the results? Well, rule 1, report the error with 1 sig fig unless it begins with a 1 or a 2. In this case, it begins with a 2, and that 7 will have it round, so 0.0025. Rule 2, report the answer with the same precision, 6538. Rule 3, are you doing better or worse than the instrument? Well, the instrument error is 0.001. So we can't use this. We have to use the instrument error, right? And that will not round. So 72.65 plus or minus 0.001. Okay, so you create 3 solutions to test your new artificial sweetener. You weigh the compound on a balance that has a precision of plus or minus 0.0001 gram and use a burette that has a precision to 0.01 milliliters. You calculate the concentration of each solution using a calculator. The calculation for the first solution is this. The average concentration sample standard deviation for the 3 solutions is this. How should this result be reported? Well, rule 1, we report the error with 1 sig fig unless it begins with a 1 or 2. So we have 1, 2, 3, 4 zeros, and that 6 will have it round. So 1, 2, 3, 4, 7. Now report the answer. 1, 2, 3, 4, 7. Okay, is that right? 6, 8, yep. And then we have to compare the instrument error to the standard deviation. So here we have 1, 2, 3, 4, 6 sig figs. Here we have 1, 2, 3, 4, 6 sig figs. And here we have 1, 2, 3, 4, 5 sig figs. So 1, 2, 3, 4, 5. This would be our uncertain digit, which means our uncertainty has 1, 2, 3, 4 zeros and a 1. So 1, 2, 3, 4 zeros and a 1. Right, so that's our instrument error. Obviously it's smaller, so we're going to keep the actual value. So it's the answer here is C. So same question, everything here is the same, just different numbers, right? And so rule 1, I'm going to report my error with 1 sig fig unless it begins with a 1 or a 2. In case this is a 2, that 8 will have it round. Rule 2 would be 148.48. Rule 3, how is this against my instrument error? So let's figure out my instrument error. 1, 2, 3, 4, 5, 6 sig figs. 1, 2, 3, 4, 5, 6, 7 sig figs, and 3 sig figs, which means this is my third sig fig. That is my uncertainty, which means if that's my uncertainty, my instrument error is plus or minus 1. So plus or minus 1 is way bigger than 0.23, which means we can't use this. So I have plus or minus 1, and then this 4 will not round, so it'll be 148 plus or minus 1. So the answer here is E. Once again, the exact same question, just with new information, new data, and solve the same way. Rule 1, report the standard deviation with 1 sig fig unless it begins with a 1 or 2. This begins with a 2, so I'm going to keep 2, and that 9 will have it round up. So it's 1, 2, 3, 4 zeros, and then that 3 will round up. But remember, because it begins with a 3 now, I have to remove this. I then match it to my error, 0.0001, and that 5 will have it round to a 4. And then I compare this to my instrument error, 3 sig figs, 5 sig figs, 5 sig figs. So my uncertainty is in the third sig fig, or 6 decimal place. So 1, 2, 3, 4, 5, 6. So what's bigger? 5 zeros or 4 zeros? Of course, 4 zeros are bigger, and so the answer is D. You buy 2 identical speedometers and install them on the same race car. The speed is measured 50 times and the average standard deviation calculated. Speedometer is 200 plus or minus 10 kilometers per hour, and speedometer B is 300 plus or minus 15 kilometers per hour. A laser determines the car is truly going 250 kph. Select one. Okay, so we have to understand accuracy and precision for this. So let's do, So let's do the math. Okay, so let's do RSD first. Let's look at precision. So for A, I have 10 over 200, right? So that'll go to 1 over 20 times, of course, 100%. And then this one I have 15 over 300, which goes to 1 over 20. So we can see here quite clearly that they have the exact same precision. Okay, let's do percent error. Absolute value of 200 minus the real value, 250, divided by 250 equals 50 over 250, right? 1 over 5 times 100, of course. And here we have 300 minus 250 over 250, which solves to 50 over 250, or 1 over 5. We can see they have the same accuracy. So neither is more precise or accurate than the other. None of the statements for this question are correct. 17. Select the false statement. The standard deviation reflects the probability of repeating a measurement. That is true, right? That's exactly what standard deviation. That's exactly what standard deviation does. Random errors shift the results in both directions. Well, that's true, right? It shifts them in both directions. Systematic errors always have a Gaussian distribution. Ooh, that is false, right? Random errors do that. Systematic errors, in theory, can be identified. Absolutely true, right? That's our assumptions. We're identifying them. RSD allows the comparison of precision between instruments. Yes, that is true. So the false statement is C. After 99 trials, the average mass delivered by a pipette is 200 grams with a standard deviation of 5 grams. If you perform a 100th trial, what's the probability the mass will be between 185 grams and 210 grams? Select one. So let's do our Gaussian. RH 200. So I have 205. I got 210. I got 215 for 3 standard deviations. I got 195. I got 190. I got 185 for 3 standard deviations. So right, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Okay, so we want to know between 185, right, and 210. What's the probability to be in there? So let's solve this. For me, the easiest way is to see that it encompasses 1 standard deviation easily. It encompasses the 2 standard deviations completely. And then it encompasses half of that one. So we remember here that this area is 95% and that this area is 99.7. So we need to know what these two areas are, right? So that's pretty easy. That's 99.7 minus 95. And that's going to give us 4.7. So these two question marks, these areas sum up to 4.7. But we only want half of that. So 4.7 divided by 2, of course, is 2.35. So this here is 2.35. So I have 95 for this plus, so I have 95, right, plus 2.35. 97.35. The answer is C. Okay, select the true statement about RSD. The sample average approaches the population average as the sample RSD population approaches the population RSD. This is patently, right, false. Right? The sample average approaches population average when small n approaches big N. Under no other circumstances does it occur. We're going to skip B. The sample RSD equals the population RSD when the sample average equals the population average. This is also false, right? Because you can go back and forth across this population average multiple times on your way to actually the population. So that will not occur. Sample RSD will approach population RSD when N approaches big N, right? When the sample approaches the population. Right? D. The sample percent error approaches population percent error when the sample average, once again, approaches the population error. Absolutely false, right? It's only when N approaches big N. Okay? So, more than one of the other statements is true. That is now false. So the answer to this question is none of the other statements for this question are correct. There are no true statements about RSD. So, how should you report an average and its corresponding standard deviation? Right? The average should be reported to the same decimal place precision as the standard deviation. Yes, that's absolutely true. The average should be reported to the same precision as the standard deviation. That's literally rule 2. The average should be reported with one significant figure, unless it begins with a 1 or 2. It's not the average that's doing that, it's the error that's supposed to be doing that, the standard deviation. The average and standard deviation should have the same number of significant figures, and the same number of decimal places. While you may be able to argue the same decimal places, it shouldn't have always have the same number of sig figs. That doesn't happen. The average and standard deviation should have the same number of significant figures. Absolutely not. None of the other statements for this are correct. That is false also because A is correct. Select the true statement. The percent RSD provides, The percent RSD provides information on the relative precision of one measurement to another. That is actually what it's supposed to do. Random errors can be compared by calculating the percent error. No, random errors are compared by comparing RSD. Repetition of measurements will make random errors smaller. No, you just know the error better. If you have a crappy pipette, no matter how many times you do that measurement, that pipette doesn't magically become a good pipette. Systematic error is known better with repetition of measurements. No. Random errors, systematic errors, you'll never be able to determine it by doing more measurements. That's the nature of it, right? If you have a ruler that is too short, everyone will always measure too tall. You will never see it. Systematic errors reflect statistical fluctuations associated with a measurement. No. Also false. That is random errors, right? So the answer, of course, is A. Okay. You have a balance that is incorrectly calibrated and weighs weights that are too high. You use this balance to measure the mass of the beaker multiple times. Select one. The miscalibrated sample standard deviation cannot be calibrated. That is false. You can calculate it, no problem. Okay? You cannot predict if the miscalibrated sample standard deviation is smaller or larger if it were calibrated correctly. No, you can predict. Right? The miscalibrated sample deviation is larger, the same, or smaller than if it were calibrated correctly. Right? And we did this measurement. We noticed that the sample standard deviation did not change for our system. Right? We did this in the videos with the scale that was miscalibrated in the bathroom. So the miscalibrated sample standard deviation is the same as if it were calibrated correctly. What is the correct reading for the bureau on the right? Notice how it's going from small to big, so it's obviously greater than 12.31 but less than 12.32. So 31, 31, 1, 31, 2, and then, I don't know, maybe an 8 or a 9 here. We'll go 8. So it should have 4 decimal places. The correct answer should be have a 3, 1, and be 4 decimal places. So not 4 decimal places, too many decimal places. These are beginning with a 3, 2, so incorrect. The only one that could possibly be right is this one. That's the only one that has the correct sig figs and is reading the correct direction. You buy new tires for your car. The technician calibrates your speedometer to your new tires. Okay. After months of driving, the tires become warm and the diameter gets smaller. Select one. So think about it, right? You have a tire, and this tire has to rotate, right? Turns your speedometer. As the tire wears, in order to cover the same distance, it has to rotate faster. In fact, as it wears even more, it has to rotate even faster. So notice that it goes a speed, faster, faster. It never goes slower. It will never have to rotate slower to get the same speed, right? So that's a systematic error, always in one direction, okay? So this decreases the precision, right? False. This creates a systematic error on the speed reported by the speedometer. True. This creates a random error. No. False. This increases the precision of the speedometer. False. The variance of the speedometer will always be 0. That's just, I made something up that looked good, right? So the answer here is B. Okay, so this was the most challenging, difficult question on the exam. This is what caused me to go from 27 perfect scores I should have gotten to around 5. It looks innocent, but it is not. So you can see that we're taking some logarithms, right? And we're adding, we're subtracting, adding and subtracting the same rules, them together. And then you're saying, okay, well, if I'm adding things together, right, I should really just look at the decimal places, because if I have something with maybe 3 decimal places, adding it to something with 5 decimal places, and then adding it to something with 5 decimal places, that I can only keep those 3, and so my answer should have 3 decimal places. And that's the correct way to solve the problem. It's perfectly correct. You'll see that this has 3 sig figs, so that this will have, it has 3 sig figs, so this will have 3 decimal places. This has 5 sig figs, so it'll have 5 decimal places. 5 sig figs, 5 decimal places. 5 sig figs, 5 decimal places. So this is absolutely the correct way to solve it. And this is probably what you did, right? And so the answer is 8.1 times 10 to the minus 2. Now, you're probably saying to me, that does not have 3 decimal places. What are you doing here? Let's take my answer here. Let's rewrite this answer. This answer is 0.0813469. And if I take 3 decimal places, there they are. So that is this number. I just obscured this using scientific notation, and then it further obscures it because it looks like it has only 1. So a lot of people will choose this, or a lot of people chose that. And so this was really a challenge, right? Because the correct answer, of course, is D. So this was the more challenging one. Right? There's, scientific notation, so it's not that I'm just being a little sneaky here. I'm hiding this 0 from you. But I'm telling you it's there. You just had to take a look. And if you got that right, congratulations. Very good job. That's awesome. Other than that, that's it.